So good afternoon. My name is Rodd Novak, Chief Marketing Officer at Peregrine Semiconductor. I'll be talking today a little bit about what we do and our technology. We're a group down in San Diego that produces UltraCMOS, a technology most people said couldn't be done, and our mantra was changing RF design forever. And I'd say mission accomplished on that feat. From that time, we've amassed over 1,500 customers, 190 products in 50 countries. The markets we cover are quite diverse, from cellular handsets, where we're number one in RF switching devices, through medical, through automotive, through space, through infrastructure, both wireless and cable, as well as broadband applications. What I wanted to talk a little bit about is our technology and our recently announced STeP8. But to start off, UltraCMOS in general. We take the best of two worlds. We take CMOS technology, and we marry that with a very perfect insulator, sapphire. Sapphire is basically a single crystal alumina that has a resistance of 10 to the 14 ohms. And marrying those two together provides you with, again, all the benefits of CMOS, but very high performance RF capabilities, RF passives, as well as digital on a single technology. Now, we've been using this since, 2000 timeframe. Entered into the cellular handset market around 2004. The rest of the markets grew from there. We entered with a STeP2, and STeP stands for Semiconductor Technology Platform. And one of the ways we measure how good of a product that we can make is R on, C off. So if you look at it, the basic FET as a two-terminal device. When that FET is on, it has a resistance component, or R on. When it's off, it looks like the capacitor, or C off. The product of the two, R on, C off, is a figure of merit, as I mentioned, which provides for how good of a product it is. We entered it with R on, C off at 768. That was STeP2. We were very successful with that, taking on compound semiconductor devices such as gallium arsenide. But we've been able to improve that year on year, actually 20% year on year. Last year, I announced this STeP5. That was February 2012, and we had a 253 femtofarad R on, C off. At that point, we were the best in the world. We had capacity what gas was capable of doing, and again, at 20% year on year versus gas 20% perhaps in the last 20 years, we're on an accelerated roadmap that we haven't seen anyone be able to keep up with. With that point, we became the number one in the market with products that we were able to produce, specifically RF switches, and this year, we announced STeP8. STeP8 came in at 179 femtofarads per R on, C off. That's a 36% improvement year on year, and a greatly accelerated roadmap well down the road when people thought we would actually plateau in our capability of improving. I can tell you right now that we're not done. We have devices in the lab today that are going to continue to improve this performance, so stay tuned, and we'll take what we have as best in the market and continue on in the future. And it's not just for competitive reasons, it's to keep up with market requirements. There's an insatiable demand out there right now for data. That data is pushing modulation schemes, and to do that, we need better performing devices. Peregrine has been a leader providing what the market needs at the time the market requested. So we were first to market when 3G hit in 2004-2005 with a requirement of an IP3 of approximately 67 dBm. No other technology could do it. We entered the market with our product hitting that, exceeding that actually, and in so doing captured the majority of the market share for the original 3G products out in the field. When 4G hit, and the request was closer to 72, we again, with STeP5, were the first ones to be able to provide that and capture most of the very tough slots for devices touching the cellular antenna. Now we're looking at what I'm calling 5G LTE bands, basically carrier aggregation, which is causing significant problems in the marketplace for people who are trying to use the bands that they didn't have. A well-published one would be AT&T that's using band 17 and band 5 for CA, but if you look at band 17 for an uplink, it has a third harmonic going directly onto band 5, meaning they cannot use the band 17 for uplink for CA. So the most precious commodity, which is their bandwidth, is being limited because of the linearity capabilities of products today to touch the antenna. We have STeP8. We announced it. It has over 80 dBm IP3 in the products that we're producing. We believe that's going to help solve many of the CA requirements, and as these new products come out, next year, we again will be the only ones that will hit the mark and capture the majority of the share. If you take the RNC off graph that we have, if you apply it to where we look at linearity improvement, we're somewhere between 2 to 3 dB of IP3 improvement, linearity improvement year on. And again, from a roadmap standpoint, we don't know any other technology which is improving at that rate year on. Visually, to take a look at what I'm identifying is gas competitor with a side-by-side comparison of an STeP8 switch. This is sold in the cellular handset market. In 2007 and 2013, the gas group has done some good things when it comes to performance. They still need a DC-DC and a decoder, which is done in CMOS, to drive the gas device and linearity requirements. They have to package that up and deliver it because most customers can't handle the solution set as die form the way they have it. For us, we entered with STeP2 in 2007. You can see when I launched STeP5 last year, we were actually 83% smaller, or our device was 17% the size of the gas model. This year we launched STeP8. We reduced the size again by half over STeP5. And I'd hasten to say that this is probably the last time I'll ever compare our technology to gas. We believe that we've displaced it in the cellular handset, in the switch category, as well as new categories such as tuning technology. And in fact, I'm sitting on a panel tomorrow called the Death of Gas, specifically for what we've done by introducing SOI technology into the client and cellular handsets. The other point I just wanted to show was how quickly we were able to ramp this from basically the first year of launch to the first 3 quarters to over 200 million. Brand new supply chain, brand new fab, brand new technology. Yet because it's CMOS and because of the fabs and this industry, we are several generations back. This technology is at 250, actually STeP5 is at 350 microns. The capacity, the knowledge, the capability of launching that high volume immediately is an easy thing to do. So I identified our technology, which is being driven by the cellular market when it comes to the speed of our roadmap, but we're applying these to many other market segments. And we're not only stopping in the area of the front end of the handset, which has limitations of, let's say, up to 3 gig and power handling at 36 dBm. We're looking to push our UltraCMOS technology into higher frequencies and to higher powers. So we cover quite a few markets. Mobile wireless, as I mentioned, wireless infrastructure, broadband, testing, measurement, industrial, space and defense, with quite a few product families, from attenuators, synthesizers, gain amps, DTCs, which are tunable components, DC-DC converters, and we're sampling right now phase shifters and several other product categories that you can come over and see at our booth. But specifically, what we're here to talk about is a push to higher quality, so AEC certified devices that can go into the automotive market, higher power products, again done on CMOS, high isolation, and push up to high frequency. One of the products we're launching here is a 13 gigahertz switch on our UltraCMOS device. Now it's the combination of power handling, so 36 dBm at 13 gigahertz, and maintaining linearity. IP3s of 65, IP2s 115 dBm, that was measured at 8 gigahertz. And this all with 3 kV HBM. So the combination of power, linearity, low loss, and isolation, we don't see any other product in the market today that's capable of delivering that kind of performance. This product specifically is being highly sought after by the ATE market, one of the markets which we service. They like the highest performing devices, they like devices that switch very fast, very predictable, and they're also a leading indicator into what the market is looking at. So as they take on our devices, they see them proliferate out through other markets, but this one specifically we're showing here as a test and measurement switch. I'm sure it will make its way into infrastructure, broadband, and many others. We also have a digital STEP attenuator. This device is an extension of our already award-winning STEP attenuator line. This is a 7-bit DSA, meaning it has quarter dB steps up to 31.75 dBm of attenuation. It's a monotonic at quarter dB step up to 6 gigahertz. And it also works up to 8 and 1 dB steps from the monotonic. The point is that from 9 kilohertz to 8 gigahertz, it has a linearity of 61 dBm. Its worst case across the entire band, and it has a PN of 28 dBm, so it's at least 60 dBm higher power handling than our previous capability, as well as 5 gigahertz higher, moving up to 8 gig in the frequency standard. Again, that combination of power, linearity, and broadband performance that we have is what's new. As I should mention, all these products are now being delivered on STeP8. This is still a generation back when it comes to technology node. But what we find is that most of these products, what I'm considering high performance solution environments, broadband, space, etc., usually are one generation back. And then we launched very high volume markets in cellular to get the supply chain rock solid, get the volume moving, and then we bring our more, I would say niche, but our more specialized product categories into that node 5. So 1 year back. This is a very interesting part. It was put together for the push-to-talk radio guys in Homeland Security, which are now putting more and more devices into their push-to-talk radios, from LTE down to the fire and the police bands. The issue is power. This device actually puts out and can support 40 dBm, 10 watts of power at 8-to-1 Bismarck, yet maintain linearity of 82 dBc at a second and third level. It actually operates out to 45 dBm. So it's really a 17-watt switch, and into tough Bismarck conditions, and still maintain performance. The loss of this device, worst case is 0.35. Typically, it's about 0.2 dB of loss. And the interesting point is you can configure it as either 3T or 5T. So if the end customer says, I only need a 3T here, and I want better performance on that port, you can gang out 2 of the ports and get down to 0.15 dB insertion loss, which is almost good as promising medicine. Yet, handle 40 dBm of power and the linearity, which as far as I've seen at 82 dBc, at that power, at that Bismarck condition, that's the most linear switch in the world today. And this again is a SP5T, not just a 2T. So very much more difficult than a 2T switch. And just quickly to make sure I can introduce one of our other products, digital tunable capacitors, is something we're showcasing at our booth. What we've done is taken our world-class switches, we've applied a binary weighted bank of capacitors, and we're able to produce a tunable component in a very small size with a digital serial bus on. So write a word and out comes a capacitance that's high Q, it's monotonic support in a very, very small size. People are using this for tuning antennas in handsets, making them half the size. They're using it for notch filters. They're using them for filter tuning, basically anything else we possibly think of. Tweaking phase shifters, keeps matching out with creatives. Lots of opportunities to use this technology. We built a host of devices with different capacitance ranges, anywhere from 0.9 up to 7 pop. They have different step sizes from 115 femtofarads based on what type of precision that you're looking for, but they're all very easy to use. It's 2x2 millimeter light packages with good power handling of 34 dBm and superior linearity of 65 dBm, because it's going to be touching the antenna where linearity is extremely important. But with that, I'm out of time. And I do believe if you come over to our booth, you'll see these DTCs in action. We have live demonstrations of tunable notch filters, live demonstration of a very complex architecture, specifically this device, where we've monolithically integrated multiple DTCs, bypass switches, as well as conductors that you can put on and off the device. By doing that monolithically, you get rid of all the straight capacitances. You have the sapphire connecting between the two products. And you can actually watch the constellation move and try and track the antenna as it is pulled in and out of two, let's say 2 element on a sleep chart. And we think that carrier aggregation, this device, along with some of our other DTCs, are going to make a great splash. We've already seen many customers do NFC, M2M, and other RFID type applications that I'm presently launching this product and using it across multiple platforms. And that's it. Thanks.
That was perfect.